Hello everybody, after long time in front of you with physics formulas which are useful for all kind of competitive exams related to physics, right? And now we need the basic formulas which are used to solve the numerical problems asked in the competitive exams, right? So now actually here physics have two kinds of quantities. One we call it as scalar quantity, other we call it as vector quantity, right? The scalar quantity means that quantity which has only magnitude without direction, and vector quantity is that which has magnitude as well as direction, right? Now here if we go for the shop, if we want to purchase the rice, what we will say? I need 10 kg of rice, or 50 kg of rice, or 1 quintal of rice we will say. So this kg, 10, 50, 1 quintal, this all comes under magnitude. Now if for example if we want to explain the velocity or speed of car, then what we will say? The car is moving with 10 kilometers per second along north direction. So this 10 kilometer per second indicates the magnitude, the north indicates the direction. So here we require the magnitude as well as direction. So some physical quantities require only magnitude, such as mass, time, etc. Some physical quantities require magnitude as well as direction, such as velocity, acceleration, etc. Right? Now, if we want to know the formulas, we must know about these scalar and vector quantities to define formulas perfectly, right? So now here in kinematics or mechanics, number of formulas are there. First one, let us start with distance. Distance means what? Here a person started from his home, right? He want to go to market which is located at position B. So now here this becomes his initial position, this becomes his final position. The length between these A and B we call it as distance, and such distance is a scalar quantity, right? Now let us talk about displacement, right? So now here displacement, it will indicate the direction the person is moving from A to B. So one is the path travelled, right? At the same time the direction also we are indicating. This we call it as displacement. So from A to B, the person can go directly from A to B, or in such a way, the direction which I drawn, or in such a way. So three different directions I drawed. Here the person starts from home and reaches the market in any one of the direction. But here A to B is the least or least distance which he have to travel. So this least distance traveled by the person, we call it as displacement. Okay, the least distance traveled by the person in a particular direction, we call it as displacement. Now such displacement is vector quantity. Now I think you got a clarity about scalar and vector quantities. Now let us define some basic definitions such as speed. Speed is defined as distance travelled by time taken. S is equal to d by t. Velocity is defined as rate of change of displacement. In physics, rate means something divided by time. That we call it as rate. The rate of change of displacement, we call it as velocity. Such velocity is vector quantity. Right? Now here it is written as d by t. T is scalar quantity time. D by t. And if we go for units, either for speed or velocity, meter per second. Here also meter per second. Right? Now next, acceleration. Okay. It is also a vector quantity. It is defined as velocity, rate of change of velocity, v by t. Right? Or we can also write as, if v is the final velocity of a object, u is the initial velocity of a object, then acceleration is defined as v minus u by t. Acceleration is defined as v minus u by t. Right? So velocity d by t. Right? Now here next, acceleration, rate of change of velocity, or it can also be written as v minus u by t. Right? Now similarly, let us move for some kinematics relations. Please note down in your notes. It will be useful for you while doing numerical problems. If v is the final velocity of a particle, u is the initial velocity, s is the displacement of a particle, t is the time taken for a particle to travel particular or undergo particular displacement, g is the, or a is the acceleration. Then kinematic relations are v equal to u plus at. Right? V square minus u square equal to 2as. S is equal to ut plus half at square. Now, or Sn, another relation, Sn is equal to u plus a by 2 n minus 1 into t. So this we call it as kinematic relations. In this kinematic relation, we are talking only about motion of body without involvement of force. Motion of body without involvement of force. Right? Now, here, whatever the velocity acceleration formulas I talked in terms of linear motion. So what is linear motion, or this can also be called it as translatory motion. We can also call it as translatory motion. So linear motion means if a particle moves in straight lines, we call it as linear motion. But every time it moves in straight lines means not necessary. Particle even follow the curved path. Either it can move in straight lines or in curved path. So such motions we call it as translatory motion or linear motion. So whatever the formulas we discussed, either kinematic relations, velocity, acceleration, are related to this linear motion. Now we also have circular motion. Alright. Now next let us move for circular motion. So circular motion, or we can also call it as rotatory motion. Now I am taking XY plane, right? 0 is the origin. First let us think that particle is at position P, right? Now from P the particle in such a way, right, it has reached P dash, you think. Now this OP now comes to OP dash. Now here we want to specify the position of particle. To specify the position of particle, we need two coordinates. First one, the radius vector, or we first let us say it as position vector. What is the position vector? The distance of particle from origin to its position, OP dash. Now if we complete this, it comes in form of a circle. So this can also call it as the radius vector. So OP dash we can also call it as a radius vector, right? OP dash we can also call it as radius vector. The second coordinate which is used to specify the position of particle is angle. Now see here, the position vector OP dash is making certain angle with x-axis. So now we can say that the particle from P to P dash has undergone angular displacement. It is making certain angle and moving with respect to the origin. So we can say that the particle has undergone angular displacement, right? Now let us denote for infinitesimal changes, let us denote with delta theta. Now delta theta becomes angular displacement of the particle. Now the velocity can be defined as the rate of change of angular displacement, right? The rate of change of angular displacement, we call it as angular velocity, and such angular velocity is denoted by omega, a Greek letter omega. So this is written as, if we apply the limits delta theta by delta t, it becomes d theta by dt. So angular velocity is defined as rate of change of angular displacement, and linear velocity is defined as the rate of change of displacement. xp the displacement. This is linear velocity and this is angular velocity, right? Now next, the rate of change of angular velocity, we call it as angular acceleration. and this angular acceleration is denoted by letter alpha. It is written as delta. Delta omega by delta t, instantaneous angular acceleration. Now next, angular acceleration. Now instantaneous we get by applying limit delta t tends to 0. Delta omega by delta t. It converts into d omega by dt. So angular acceleration is d omega by dt. So linear acceleration, rate of change of velocity. This is linear acceleration. This is angular acceleration. Right? So I think you understood the difference between the linear motion and angular motion. Right? Similarly, we can also write the kinematic relations in terms of angular or circular motion or rotatory motion or rotational kinematics. Now here we wrote this is in case of linear motion. Now rotation motion, how you will write? In place of final velocity, you write it as final angular velocity omega 2. Initial velocity, let it be initial angular velocity omega 1 plus acceleration we are denoting with alpha into t. Right? This also omega 2 square minus omega 1 square equal to 2 alpha, and displacement we are indicating with theta, no, angular displacement. So in such a way we can change all this. Now this one also, theta is equal to omega 1 t plus half alpha t square. These are related to rotational kinematics. This is related to linear motion equations. Right? Now next, now velocity, acceleration, I think you get the clarity about the formulas. Now next, let us move for force. The force as per Newton's second law, we write force is equal to mass into acceleration. M is the mass, A is the acceleration, mass into acceleration. Right? Even we have centripetal force, centrifugal force, right? Now centripetal force. Centripetal force means what? The force acting towards the center, we call it as centripetal force. The force acting away from center, we call it as centrifugal force. Right? Now the either centripetal or centrifugal, the force value will be equal, F equal to mv square by r, where centripetal acceleration AC is equal to v square by r. Actually this is written as F equal to mac. In place of AC we wrote or we substituted centripetal acceleration v square by r. Right? Now next, in case of weight, what we can write the force formula? mg. Right? Now do you know the force in terms of gravitational force? G m1 m2 by r square. m1 m2 are the masses of two bodies, r is the distance between that two masses. Then the Newton's law of gravitation says that force is directly proportional to the product of masses and inversely proportional to the square of distance between that two masses. Right? Now what will be the units here? Units, let us write. Units no need of by hearting. Directly you can write Newton, or mass is taken in kilogram, acceleration due to gravity meter per second square. Now here what you can write, two masses are there, kg square by r square, that is meter square. Okay, and what are the units for g? How you can write? Or simply you can write Newton, that is enough. Now g is equal to what we can write, f r square by m1 m2. F Newton meter square by kg square. So now f, how we will write? G m1 m2 by r square, Newton meter square per kg square into kg square by meter square. What we are getting? Newton itself, no? So force is nothing but Newton, right? Now next, the most fundamental formula, work done. Now we talked about force, no? When we apply the force on any body, then body what happens? From A to B it displaces. If body displaces on application of force, then we call it as work done. Such work done is written as the product of force into displacement, that is equal to F into ds. Right? Now next, work done means nothing but the capacity or energy is nothing but the capacity to do work. So only work done we will take equivalent to the energy. Why we will take work done equivalent to the energy? Because work done, the capacity to do the work, we call it as energy. Now this energy will be either kinetic energy, which is half mv square, or potential energy, which is mgh. Right? Now in case of springs, this potential energy is written as half kx square, where k we call it as spring constant, x as usual displacement. Right? Then force can also be written in terms of spring constant, minus kx, F equal to minus kx. Right? Now this is kinetic energy, we call it as translatory kinetic energy. Translatory word I used means, there will be rotatory kinetic energy? Yes, there will be rotatory kinetic energy. Such rotatory kinetic energy is written as half I omega square. Half I omega square. Then what is I here? I we call it as moment of inertia. I we call it as moment of inertia. And such moment of inertia is written as mr square. Now what is this mr square? Now if we take any rigid body and let this be the axis of rotation. What is axis of rotation? That axis around which the particles will rotate. Now I took one particular particle here. Let m1 be the mass of that, or m be the mass of that particle. Now this particle rotate around this axis of rotation, and a circular path is traced out. Now let this be the distance, or CR I am writing, the distance of particle from axis of rotation. Now see, this distance is perpendicular to the axis of rotation. So here that is equivalent to the radius of that circular path. So now here m becomes mass of the particle, r becomes the perpendicular distance of the particle from axis of rotation. So moment of inertia is defined as the product of mass of a particle and the square of perpendicular distance of a particle from axis of rotation. Right. Next term is omega. Right. Omega. So omega we call it as angular velocity or angular frequency. Here omega value will be equal to angular frequency we are writing 2 pi nu, where nu we call it as frequency. So do you know what is frequency? Number of oscillations per time taken. That we call it as frequency. Or if we consider one oscillation, T becomes time period. Then what is time period? What is time period? Time period is nothing but time taken by a body to complete one oscillation. One oscillation. See, in one particular formula we can derive number of formulas. Right? Now with kinematic rotational kinetic energy, I wrote I half I omega square. I am defining angular frequency. Right. Now here frequency means 1 by T we wrote no. If we substitute in place of frequency, it becomes 2 pi by T. In terms of angular frequency, time period can be written as 2 pi by omega. Now pi, radians. Okay. Now if all strikes off, we get seconds. Now this is radians per second. Time period, seconds, minutes, hours, anything you can take as units. And here the omega, radians per second. Right. Now next, now we wrote about the kinetic energy, potential energy formulas. Now in rotational kinematics, you see, I am taking an inclined plane in such a way. First, body is at a certain height. When it is at height, it has potential energy. Right. Now as it is an inclined body, it slides down and comes to the bottom. Now see how the motion, one it is coming in a straight line, means it is having translatory motion, and it rolls, so it is having rotatory motion. So according to law of conservation of energy, what we can write? Potential energy at the top of inclined plane will be equivalent to the rotational kinetic energy plus translation kinetic energy. Right? What is rotational kinetic energy? Half I omega square. What is translation kinetic energy? Half mv square. Okay. So this can be equivalent to the total rotational energy. Rotational kinetic energy plus translation kinetic energy can be taken as total rotational energy of rolling body, which will be equivalent to the potential energy when the body is at a certain height from the ground. Right. Now similarly, now let us go for some other definitions such as linear momentum. P, mass into velocity. Then you might also have angular momentum. It is denoted by L, or in some books he will use capital J. L or J. What will be? I omega, moment of inertia into angular velocity or angular frequency. Angular frequency. I omega. Now see, according to Newton's second law, when external forces act on the body, that external forces will be equal to rate of change of angular momentum. Right? Now, according to law of conservation of angular momentum, the rate of change of angular momentum will be equal to d by dt I omega. I constant d omega by dt. What is d omega by dt? Angular velocity. The rate of change of angular velocity, which is nothing but angular acceleration. And I into alpha, we call it as torque. So torque will be equal to dl by dt. Then what is this torque? Torque is nothing but if a body want to move or undergo rotatory motion, first it needs to have a small turn. Then only if it has a small, now body is here, it wants to undergo rotatory motion, first it has to turn. No? This turning effect of force, we call it as torque. Right? Turning effect of force. So torque is defined as the product of force and perpendicular distance. Okay, between the forces. Now next, similarly, angular momentum is written as r cross p. P is the linear momentum, so r cross mv. P is nothing but mv, I said. Okay. Now rmv sin theta. If theta equal to 90, sin 90 value 1. So mvr is the angular momentum. Linear momentum means you substitute mv. Angular momentum means mass into velocity into distance. Do you know the relationship between linear velocity and angular velocity? This both v equal to r omega. Now let us substitute here. No, what we will get the formula? See, r into r square, mr square omega. If you want to convert more, mr square 2 pi nu. Right? Omega equal to or mr square 2 pi by t. In any way, how he is asking you the numerical problem, in that way you can go on changing the formula by substituting the related formulas in them. Right? This is about angular momentum. Right? Now next, up to where we completed linear momentum, angular momentum, torque. Okay. Now next, let us go for, I defined oscillations. No, I said frequency. I defined frequency, number of oscillations taken place per unit time or per second. Right? Then what is that oscillation? Right? Let us move for that oscillations. As my formula is proceeding, I am going on proceeding along that formulas itself only. So better to note down. Okay. Then what is this oscillation? No? What is this oscillation? Now I took a simple pendulum, a bob tied to a string or a wire thread fixed at one end. Let this be the mean position or equilibrium position or rest position of the simple pendulum. I took simple pendulum. Now what I did with my hand, I displayed the pendulum to in this direction. Let it be x or y, your wish. But whether pendulum stays here? Never. Again, the restoring forces generated in the thread makes the pendulum to move towards the mean position. Okay, that is, restoring forces direction is towards the mean position. Galileo said that Force is there means body is undergoing acceleration. Means the direction of acceleration is towards mean position. But will it stay at mean position? No. Again the pendulum comes to this position, displacement. But restoring force or acceleration will be towards the mean position. Right? Now see, from mean position, once the pendulum is going on this side, again the pendulum is coming on this side. So this to and fro motion of a pendulum, we call it as oscillation. Now here the other term is also there, vibration. The definition is same, to and fro motion. Then what is the difference? Both are having same definitions. Both we are saying to and fro motion, but we are calling one as oscillation, other as vibrations. The difference lies in angular frequency. If angular frequency is less, then we call it as oscillations. If angular frequency is more, we call them as vibrations. Right? Now here you see, displacement is in this direction, acceleration is in this direction. Right? Now line of action is same. Line of action is same, so we can write acceleration is directly proportional to displacement. But see, direction is opposite, so in opposite direction. This we call it as simple harmonic motion. So what is simple harmonic motion? A particle performing to and fro motion about mean position is such that acceleration is directly proportional to the displacement but in opposite direction. Now depending upon simple harmonic motion, velocity is written as a omega, acceleration minus omega square x, proportionality constant, where omega angular frequency, so minus omega square x, a equal to next formula, already we defined the frequency, time period, we wrote the formula for angular frequency. Right, next one, this we call it as now amplitude. Now here I am drawing the oscillations. This is the mean position, you think, positive y-axis, negative y-axis, plus y, minus y. Right? So this is the maximum displacement. Maximum displacement of a body, we call it as amplitude. Right? Now next, phase. Phase means that particular physical quantity which explains about the state or position as well as direction of particle. Direction of a particle, we call it as phase, and this explanation will be done in terms of angle, right, and denoted by theta. Okay, now next, phase difference. If there is a difference of angle or phase between any two particles, we call it as phase difference. Now theta plus omega t indicates the phase. Okay. Now next, this is about phase and phase difference. Next we are also having propagation vector. Propagation vector denote with k, 2 pi by lambda square. This we call it as propagation vector. Okay, this is related to the oscillations. Now Next, some vector product, scalar product. So vector product can also be called it as cross product. This we call it as dot product. If we take two vectors, the cross product between two vectors we call it as vector product, and it is AB sin theta, and n is the unit vector along the vector. Okay. Now next here, the dot product between two vectors A dot B we call scalar product. Here we will get AB cos theta n unit vector. Now next here, why we will call it as scalar product means the answer will be scalar. Here why we will call it as vector product means the answer will be vector. Alright. Now this is about the vector product and scalar product. The relation between linear velocity and angular velocity V equal to r omega. The relation between torque and angular acceleration tau equal to I alpha. Right? Now these are the formulas related to mechanics as well as some oscillations also I wrote. Now do you know the displacement formula? Y equal to A sin kx or y equal to A sin omega t plus pi, where A is the amplitude, the displacement equations. Alright, pi is the phase angle, or phase difference. Now these are the formulas related to the mechanics as well as the oscillations. These are not only the formulas enough for the preparation, but you require more and more formulas to know. In my next video, let us go for that particular formulas. Right? Okay. If you like this video, like it, share it and subscribe it. Thank you for watching my video and my channel Reshma Physics.